One of those cases is quality control. You can get rapid quality control data on binding partners. And so shown here was a type of experiment that was performed where SARS-CoV-2 nucleocapsid protein was immobilized onto the sensor chip and antibodies were flown over. And there were 4 batches of antibodies from a single supplier that were flown over. And as you can clearly see, relative to the negative control shown in orange, our device was able to show that there was very clear batch-to-batch variability. And now moving away from quality control, where is another clear use case of our platform? Well, that is in our platform can allow you to speed up your lateral flow assay development. And what is it that allows us to do that? Well, on our platform, you can analyze the same complex biological samples as LFA. You can adapt antibody immobilization strategy as a model for LFA development, as in the immobilization step on our platform is very much analogous to the immobilization step that you perform on an LFA. And then before actual LFA development, you can perform pre-screening feasibility studies. You can test antigen antibody complexes to test the feasibility of your system. And then on our platform, it allows for simple and rapid assay optimization studies. And now moving away from LFA development, where else can our platform be helpful? Well, it can very clearly be helpful in the context of ELISA, where on our platform, it is less steps and real-time detection right away. And so shown here is the typical workflow that I've shown previously. And shown here is the typical workflow of ELISA. And as everybody knows, you have your immobilization step where you put in your primary antibody, you'd block with BSA, add your antigen or analyte, you add your secondary antibody, and then through the addition of substrate, you get color development. And shown here is the clearly large number of washing steps, and what is not shown is the incubation steps. And so on our platform, it is a much smaller amount of steps, and also the time investment is also much smaller. This is on the order of an hour, as opposed to in ELISA, it's on the order of multiple hours. And again, importantly, on our platform, it is real-time detection right away, as in you can see immobilization occurring. You can see blocking occurring. So not only does this allow you to have confidence that all these steps are being carried out correctly, it allows for easier optimization, because if you know that you have incomplete blocking and you can see that, you can take steps to remedy that situation. As opposed to in ELISA, all of these steps are largely performed having faith that these all occurred correctly.